Okay, so we look at another example, how we can determine the memory components. Okay, for example, you are given this memory component, okay, 1K time with 8 bit. Okay, so this is actually the real memory component, how you're given the value of your memory component, okay, by using a value, okay, or the unit, okay, the unit of your memory, okay, either by using K, okay, kilobit, yeah, or we have M, okay, mega, okay, and then G, yeah, so depends, okay, depends on your unit. Okay, so based on this example, 1K is actually referring to 1 kilobit of memory, okay, time with 8 bit. Okay, so you need to remember uh, the the format of your memory component. Yeah, so the format of your memory, okay, is written as 2 power of n time with m. Okay, so this is your format of your memory component. Okay, so meaning that based on this example, 1K time 8 bit, okay, so you need to change to this format, okay, so that you can find the value of your n and also m. Okay, so for 1K, okay, 1K is actually referring to 1024 bit, okay, time with 8. Okay, so based on this value, so first thing that you can determine is actually your memory cell. So how you can determine your memory cell is actually you just multiply for both values. Okay, this is the first value 1K time with 8 bit. So because 1K is actually referring to 1024 bit, so you just time with 8, so that's why you will get 8192 memory cell, 8192 memory cell. So that is the first thing that you can find, okay, based on your given memory component. Okay, you can determine the memory cells. And then the uh, second one that you can find is actually your number of address line. Okay, so the number of address line in this example is equal to 10 address line. Okay, how you can get 10? Because you need to convert, okay, 1K to this format, which is 2 power of n. So 2 power of n is equal to 1K. So you know that 1K is equal to 1024 bits. Okay, so you just find the power of 2 for the value. So you can get 10. Okay, because 1024 is equal to 2 power of 10. Okay, so that is for the second value that you can determine. Then address range. Okay, how you can determine the address range is actually referring to the first value, yeah, which is 1K or equal to 1024. So 1024 is actually referring to the number of memory location. Okay, how many location that you have in your memory. So in this example, you have 1024 memory. So the address range must contain all the memory location. Okay, but we need to start from the smallest number. Okay, which is we start with 0. Okay, 0 to 1023. So the total here is actually 1024. So that is how you determine the address range. Okay, example, if your memory location you have 32, okay, 32. So your address range here is start from 0 to 31. Okay, 0 to 31. Okay, that is how you determine the address range. And then based on this memory, another thing that you can find here is actually your word size. Okay, so word size actually you just refer to the second value, which is m. So for this example, your m value is 8. Okay, so that's why your word size here is 8 bit. Okay, meaning that in one location you can store up to 8 bit of data. So this table is actually representing the structure of the memory. Okay, so you have 1024 location. Okay, and then for each location represented by 10 address line here. Okay, so this is address line, so you have 10 address line. Okay. And then each memory location can store up to 8 bit. Okay, because the word size here is 8, so that's why you can store up to 8 bit. Okay, so you have 8 bit of data. Okay, 1 2 3 4 5 6 7 8. So each memory can store to 8 bit. Okay, can store to 8 bit. Okay. And then the value that you can find for this memory is actually the capacity. Okay, capacity of the memory in bits. Okay, so how you can determine the capacity of memory in bits? So the capacity of the memory in bits is actually the same formula how you can find the memory cell. Okay, you just multiply for both value. Okay, so for this example, okay, for 1K time with 8 bit, sorry, okay, capacity in bits is actually referring to 1K time with 8 or equal to 1024 time with 8, okay, which is equal to 8192 bits. Okay, so this is how you determine the capacity in bits. Okay, you just multiply for both value 1K time with 8. Yeah, and then capacity in byte. Okay, so capacity in byte. Okay, so capacity in bytes. Okay, you can get by the capacity in bits. Okay, divided by 8. Okay, so you already determine the capacity in bit, right? So the capacity in bit that you have here is 8192. So you just divide by your 8. Okay, why you need to divide by 8? Because you know that one byte, okay, is equal to 8 bit. Okay, so when you divide, so you will get 8192. Okay, divide by 8. Okay, so you will get 1024 byte. Okay, 1024 byte. Then next I will show you how we can draw the memory. Okay, so I show you the memory by using the simplified version. Okay, using the simplified version. Okay, I erase this one. Okay, so you draw memory. Okay, so you draw one line for each label, right? So you have 1 2 3 4 5 lines. So the first line is actually referring to input. Okay, this is for your output. Okay, this is for your RW. This is for your ME, and the last one is for your address. Okay, so this is for memory of 1K times 8. Okay, 1K times 8 bit. So RWMME only has one line. Okay, but for input and output and also address, we have a very number of value, right? So for input and output data, you refer to your word size. Okay, because your word size is 8, so input line must have 8, output also must have 8 lines. And then address line, you need to refer to your n. So you have already calculate your n. so your n value is 10. So here your address line is equal to 10. So this is how you draw your memory diagram. Okay, so basic line, you must have 5 lines. Okay, and then for input, output, and address, you must refer to the value that you have already determined. Okay, so input and output referring to M or the word size. Address line is actually referring to N. Okay, your N here is 10, so that's why the value of your address line is equal to 10. So we look at another example. Given a 16K time with 8-bit memory cell, okay, memory chip, sorry. So you need to determine the number of input and then output line, determine the number of address line, determine the word size, determine the memory cell capacity in bytes, and then draw the memory diagram. Okay, so how you can determine or calculate so this value, so you just refer to your memory component that are given to you. Okay, and then you need to change to the format of 2 power of n time with m. And after that you can determine or calculate the value. Yeah, so I show you the answer. Okay, so the first solution, okay, input and output line. Okay, because your memory that given to you is 16K time with 8-bit, right? Okay, time with 8-bit. Yeah, so when you change, okay, to the format of 2 power of n time with m, okay, so you will get okay, this one is 60K, right? 60K, okay, time with 8. Okay, so 60K ni 60K you need to convert to power of n. So you need to find the value of 60K first, so that you can find the value of your n. Okay, and then the input and output line, okay, I will show you next, okay, how you can get the value of 60K for your n. Okay, so we go to the solution first. So the first solution, input and output line is 8 line because your m, okay, your m, this is your m, okay, this is your m, so your m is 8. Okay, so that's why your input and output line is 8 line. Okay, now we can find the n value. So for the second solution, okay, so the number of address line to 60K. So this is the method how you one of the method or solution how you can find the value of your n. Okay, you know that k or 1K is actually equal to 2 power of n, which is 2 power of 10, right? Because 1K is actually equal to 1024, so 1024 2 power of 10. Yeah, so because you have 16K, so here it's actually equal to 16 times with K or 1K. So you have two separate value. Okay, so you just find what is the power of 2 for each value. So 16. Okay, so 16 is actually equal to 2 power of 4, right? And then K is always 2 power of 10. Okay, so 2 power of 4 times with 2 power of 10. Yeah, so based on this value, so you know that when the value is multiplied, so the value of your power value, okay, you can add, okay, you need to add. Okay, so that's why in this case 2 power of 4 plus with 10, so that's why you will get 14. Okay, so based on this value, so your n value is equal to 14. Yeah, so this is one method how you can find the value of your n. So other than this method, okay, you also can find the value of 16K, which is 16 times 1024. Okay, So 16 times with 1024, and then you find the value of power of 2 for that uh, results. Yeah, so that is another method. Okay, but I prefer using this method. Okay, because you always know that 1k is equal to 2 power of 10. Okay, you just find the value of the first value, which is 16. In this case, you need to find the power of 2 for 16. Okay, so 16 is power of 4. Okay, the third one is word size. Okay, word size is m, value of your m. Okay, so here you will get 8. Okay, memory cell. So memory cell, you just time all values here. 16 time with k time with 8. So that's why you will get 16 time with 1024 and then time with 8. Okay, so you get a value of 131027 memory cells. Okay, and then next, capacity in bytes. So what is capacity in byte? So previously I show you the capacity in byte. You can determine by finding the capacity in bits, and then you divide by 8, right? So that is another solution or another method. So this is another method how you can find the capacity in byte. Okay, so based on the given questions, okay, you refer to your word size, which is this one. Okay, your word size is 8-bit. Okay, 8-bit. Okay, so your 8-bit is actually equal to 1 byte, right? Okay, because 1 byte is equal to 8-bit. So that's why capacity in byte, okay, you just multiply the value of 16k, okay, which is 16 times with k, and then time with 1 byte. Okay, because 8-bit is equal to 1 byte. So that's why you time with 1 byte, so you will get this value. Okay, or you also can find the capacity in bit. So the capacity in bit is actually using the same formula of memory cells, right? So your memory cells here is 131072, so your capacity in bit also 131072. So you just divide by 8, so you will get the same value here. Okay, 16384 bytes. Okay, and then next, draw the memory diagram. So this is how you draw the memory diagram. Okay, input line you have 8. Okay, because referring to your word size. Output line also you have 8. RW you have 1 line. ME you have 1 line. Address line you have 14. Okay, because in second question you already find the number of address line. So your number of address line is 14. So here you have 14. Okay, this is the uh, example. Okay, another example. Okay, for the memory diagram. Okay, so we go for second example. Okay, second example. So given a 32k time with 16-bit memory chip. Okay, determine the capacity in bits, determine the capacity in bytes, determine the determine the number of address line, and then determine the word size. Okay, so this is the solution. Okay, the capacity in bits. Okay, so capacity in bits, you just time all values. Okay, which is 32 time with k time with 16. So you know that your k is 1024, right? So 32 time with 1024 time with 16. So you will get these bits. Okay, 524288 bits. And then the formula for capacity in bits is actually the same formula as memory cell. Okay, how you can find the memory cell. Okay, and then capacity in bytes. Okay, second question is capacity in byte. Okay, so I using the same method for previous example. So 16-bit is actually equal to 2 byte. Okay, so that's why for capacity in byte 32 time with 1024 time with 2 byte. Okay, so you will get 65536 byte. okay, or you can use another method, which is 524288 divide by 8. Okay, because type 524288 is capacity in bits, right? Yeah, so you divide by 8, so you will get the same answer, which is 65536 byte. Okay, and then C is number of address line. Okay, so number of address line, so you just refer to the first value, which is 32k. Okay, so 32k. So 32k, you just need to find the first value, which is 32. Okay, because k, you know that k is always 2 power of 10. Okay, so what is the value of power of 2 for 32? So 32 is equal to 2 power of 5. Okay, so you will get the value of 15. Okay, n is equal to 15. And then word size here is 16 bit. Okay, because you're referring to the second value, which is your m value. Okay, so based on the same question, there may be other type of questions that will ask. For example, you can draw the memory diagram, okay, and then the address range. So what is the address range for this memory? So you need to refer. So if I add another question, which is address range. So what is the address range? Address range. Okay, so you must remember how you can find the address range. First, you need to find the total of memory location. So the total of memory location here, you referring to the value of the first value, which is 32k. Okay, 32k. So what is the value of 32k? Okay, so 32k is 32 times with 1024. Okay, so you will get the value of okay, the 1024. Okay, so you will get 32768. Yeah, so your address range. Yeah, so your address range. Okay, it start from 0 until 32767. Okay, so this is how that you determine the address range. First step, you need to find the total of memory location. Okay, by using this method. Okay, and then you can find the address range. Okay, so which is the smallest address is 0, and then the largest address is 32767. Okay, so this is maybe one of the question that can be asked. Yeah, and the question may be the memory cell. So what is memory cell for this memory? So memory cell is actually using the same formula of capacity in bits. Okay, memory cell, you can use the formula same as the capacity in bits. So you must remember all the formula how you can find the value. Okay, capacity in bits, capacity in bytes, the memory cell, and number of address lines. So number of address line is actually one of the important value that you need to know how you can find. Yeah, and of course the word size. Yeah, and you can draw the memory diagram. So how you can draw the memory diagram for this memory? So I show you. Okay, the memory diagram. Okay, so you have basic 5 line. Okay, so here is input, here is output, this is RW, this is ME, okay, this is address line. So input and output referring to your word size. Okay, because the word size is 16, so your input here is 16, and then your address line is 15. Okay, so this is how you draw your memory diagram, okay, for this memory. Okay, 32K times with 16-bit. Okay. Right, so I already give you two examples how you can find or you can calculate the value, okay, for your memory.